Okay, in this video, I'm going to go through the examples for the rules for writing Lewis structures. There are some examples on the back, and I'm going to go through each of these in case you missed class or you need some review on some of them. And then in one of my class periods, I didn't go through this one yet. So these are going to be on here. Okay, so the whole purpose of Lewis structures are to show where valence electrons are in bonding. Where are all of those electrons? Are they part of bonding? Are they lone pairs on a particular atom? That's the whole purpose of this. So step one is we add up the number of valence electrons. So we go look at the periodic table. Hydrogen has 1, but we have 2 hydrogens, so there's 2. Oxygen has 6, so we add it all up. We have 8 valence electrons. That's our first step. We're going to draw our skeleton structure. And then we're going to take all of the valence electrons we've already used up in bonding here, which would be, here's a pair and here's a pair, so we have 4. So we take our total number of valence electrons. We're going to subtract the ones used in bonding, and we have 4 electrons remaining. So our rules tell us that we want to use those pairs of electrons. They always have to be in pairs. Electrons are always in pairs. We start on the outside and work our way in, and we're trying to make everybody happy. Hydrogen never has lone pairs, never bonds to more than one thing because it only needs a total of 2. So hydrogen's happy, hydrogen's happy. And so we don't add any lone pairs here. We're working our way in. We have 4 left, so we have 2 lone pairs that we'll put on oxygen, which is good because that's going to make oxygen happy. It has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons on it, and so it's happy. And then the very last thing we want to do for all of these is double check our number of valence electrons. So here we had 8 total valence electrons. So we need to make sure in our final product, our final answer here, that we are showing 8 valence electrons. We are showing 1, 2, 3, 4, 5, 6, 7, 8. So we are. So we're good to go. So in this example here, we showed when we had just enough electrons to make everybody happy. In this one here, we're going to show what happens when we have extra electrons. So sulfur has 6 valence electrons. Chlorine has 7, and 7 times 4 is 28. So we have 34 valence electrons. We're going to draw our skeleton structure. Okay, we've used up 8 electrons already, so we're going to subtract that from the number that we have. And we get 26 electrons remaining. So these are our remaining electrons. We're going to start from the outside and work our way in to make sure everybody's happy. So chlorine has 2, so we're going to put 3 pairs on this chlorine. Now it has 8 and it's happy. So we're going to do the same thing here, here, and here. So we've used up 24 electrons, but we have 2 left. So our rules tell us that we just put those on the central atom, and that is okay to do as long as the central atom is in period 3 or lower on the table, and it is, so we're fine. On this next one, what if we don't have enough electrons? Boron has 3, fluorine has 7 times 3 is 21, so we have 24 valence electrons. We'll draw our skeleton structure. We've used up 6, so we have 18 remaining. So we're going to have 18 electrons. Fluorine needs 6 more, so we're going to put 1, 2, 3, 4, 5, 6. Same over here. Same over here. And it appears that boron is not happy because it only has 6. So we have to go look at our exceptions. So if we don't have enough, we're going to look at our exceptions. And they are group 13 and beryllium. Boron is in group 13. So these are okay if they have less than 8 valence electrons. So this one's okay. So we don't have to do anything else here. Here's another one that's not enough. O2. Oxygen has 6 valence electrons, and we have 2 of them, so we have 12 valence electrons. We've used up 2 in bonding, so we have 10 left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've run out of electrons. We don't have enough. This is not one of those exceptions. So if it's not an exception, then when we don't have enough, we're going to use a multiple bond. So I'm going to take this lone pair, and it's going to go here as another bond. So now oxygen has 1, 2, 3, 4, 5, 6, 7, 8, and this oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So they're both happy. Let's double check that this was our total number of valence electrons, which is 12. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're good to go. This was our final answer. Guess I could have done that up here too. Okay, the last one is if you have a polyatomic ion. What's different here is when we add up our valence electrons, so sulfur is 6, oxygen is 6, so 6 times 4 is 24. And this -2 is telling us we have 2 extra valence electrons because we have a -2 charge, so we have 2 more electrons. So when we add it all up, we get 32 total number of valence electrons. So we're going to make our skeleton structure. And we are going to see that we've used up 8. So when we subtract 8, we get 24 electrons. So we're going to add some lone pairs on our oxygens so that they have 8. And we've used up all 24 electrons. The one thing you have to do on polyatomic ions, one extra step, is you simply put brackets all the way around, and then you put your charge out to the side. So you are acknowledging that this is a polyatomic ion with a charge. And so these are the examples that go on the back of your rules for writing Lewis structures.